Hey, what's up guys? Today we're going to be talking about optimization, and optimization is something that you really can only get through practice, and we're going to be doing an example problem, but first I kind of want to describe what optimization is. Optimization is the type of problem where we use derivatives to find the maximum or minimum of something. Now remember in our discussion of critical points that if we have some function y versus x, and we have this over here, the slope at this maximum point over here, the slope at this point is going to be 0. So that means that if we want to find the maximum or the minimum of a point, we want to find where the derivative of the function that we set up is equal to 0. And we always want to set up the function, and this is the hardest part, setting up the function of the total of whatever we're trying to find in terms of another variable that we can find the derivative of. So let's try this problem over here. So the problem goes like this. We have a river, and the river, I'm going to do this in blue, just so you can kind of visualize it. The river goes like this, and the river is 3 miles across, like so. I'm going to draw it over here so you see that it's a river. And this oil company wants to transport oil from point S to point P, and it can do it in 2 ways. Now we could build a pipe like so, and this pipe would cost $4 per foot. And then it could also build it over land, where it would cost $2 per foot. Now that means that they're going to have to do both. So we want to find the point T where it's maximized, and we're going to do it in terms of U. At what distance U is the price going to be at a minimum? And so that's where we use our knowledge of derivatives. So we want to set up what the total cost is. So I'm going to do it in terms of TC, or later I'm just going to do C in terms of U. And the total cost is going to be what I call ST, meaning the cost it takes to build the pipe underwater, plus the total cost from T to P, which is the cost of it over land. So now I'm going to do it in terms of C, in terms of U. So I have this variable v here, but we're going to do 5 minus u because we have this 5 here and we want to leave everything in terms of u. So when you see that, that's what it means. So it costs $4 per foot. So we're going to want to convert this into miles, by the way, since there's 3 and this is 5, just to keep the units consistent. So I'm going to do 4 multiplied by 5,280. But it'll cancel out later, so don't worry about it that much. And then we're going to multiply it by the amount of feet that this has been crossing. So to find that, we have a triangle that's set up. So to find this distance d, we know that d squared, due to the Pythagorean theorem, is equal to 9, which is 3 squared, plus u squared. So d, and this is what we're going to be multiplying here, is just going to be radical 9 squared plus u squared. So we have that. Not 9 squared, just 9. Let me fix that for you. I'm sorry. Yeah, it's just 9. So now that that's done, we're going to try and find the cost of this, and this will be significantly easier. So this will just $2 per foot, and remember we want to keep this in miles, so we're going to multiply it by 5,280 just to convert it, because remember there are 5,280 feet in a mile. And we're going to multiply it by the amount that this is going through, and that's going to be, since we're keeping this in miles, 5 minus u. Now that that's done, let's find the derivative of this. Cool. So we keep this 4 times 5,280 because it's a constant. And then what we have here is the derivative of this, which is going to be, once you take the derivative, 1 over 2 radical 9 plus u squared. And then we apply the chain rule, which means that we multiply this by the inner function, and then that would be 9 plus u squared, which is 2u. Don't forget the chain rule. And this is going to be c prime, by the way. C prime of u is equal to this. And then now we're going to do the second one. So that's a constant. And the derivative of 5 minus u is just going to be negative u. So, or negative, I mean. Negative 1. So we have minus 2 times 5, 2, 8, 0. Now we want to set the derivative equal to 0. So already, we're just going to cancel this 2 with this 4, and this becomes a 2. We have 2 times 5, 280 on both. So we're just going to do, yeah, let's just do that. Cancel those out. So what we're left with here is 2u over radical 9 plus u squared rip. Let's do that. Alright, so that's going to be equal to 1. So we can multiply this on both sides, so we end up with 2u. We're going to square this, just because this is a radical down here, is equal to 9 plus u squared. So then we can subtract it on both sides, subtract u squared, and we end up with u squared. So this is going to be 3, because 2 squared is 4, so 4u squared minus u squared is 3u squared is equal to 9. And so we end up with u is equal to radical 3. So that means that we have radical 3 miles as the distance from the origin where the cost is optimized. And then if you wanted to find the cost, all you have to do is plug this in over here. So you'd plug radical 3 in, and then you'd solve for the cost, and you end up with something like $110,000. I hope you enjoyed this video. I hope you understood what it means to optimize something. So you want to find the total cost in terms of the variable you're trying to find, and then you take the derivative, and it's just as simple as that. Calculus usually takes you through the rest of it, but the first step is usually the hardest, which is setting up the problem, and that just takes practice. Give it a thumbs up and subscribe, and I'll see you tomorrow.